Let us look at more complicated situations of changing the subject of a formula. So date, title, learning, objective down if necessary. Objective to be able to change the subject. Yeah. To bat is to be able to, if you weren't familiar with that. So to be able to change the subject of harder formula. What do I mean by harder? At the moment, it's not harder. There are other lessons on this, sessions on this, but where we have, for example, in this case, where we have the square root sign, or where we have a power, or where it's fractions, adding fractions together, that sort of thing. So let's explore a couple of those. I would recommend that you get stuck in and try. I've put in the rule. I've changed it a bit. I'm not saying change side, change sign. I'm saying change side, opposite operation. It's the same thing, change sign. Changing the sign is doing the opposite operation, but perhaps this way of writing it, CSOO, change sign, opposite operation, perhaps that way of writing it might be more useful in this context. But that's the guiding principle that's going to get me through this, that will get you through this. So you use the power of the pause to have a go for yourself. That's the best way to learn, I think. Or second best way to do it is to let's do it together. And when you have an aha moment, when you think you can finish it without me, you just pause, get rid of me, finish it for yourself, get that feel good factor, and then just confirm that you've done what I've done. That's the best way, I think, of learning doing maths like this and improving your maths. Okay, good. Now that we have all of that jazz out of the way, let's get going. I want L. I want that L. Ooh, wrapped up in this multiplication. There's a square root sign. There's division by G. There's a lot of stuff going on. Ooh, this is going to take a while. I need to get L. Okay. First bit, we have this multiplying by 2 pi. Remember, left-hand side is equal to right-hand side. So I'll make those references. And the multiplying by 2 pi on the right, that needs to go over to the left because I need that L. So multiply by 2 pi needs to go over to the left. And if it goes over, it changes the side. Then multiply by 2 pi has to become the opposite operation, which is divide by 2 pi. So my first line will be T divided by 2 pi is equal to the square root of L divided by G. That's my first line there. And I write big, so we're going to have to do some scrolling. I can see that already. Okay, so we got that. Whew. Now, square root sign. Whoa, your problem. I want my L. I need my L. There's a square root affecting me, and there's a divide by G affecting me. So right now, square root needs to go over to the left-hand side, and the opposite of square root, opposite is to square, raised to the power. So the entire expression on the left has to be squared. It has to be raised to the power of 2. That's the opposite of square rooting. So on the left-hand side, I'm going to put T on 2 pi, all of it in brackets, squared is equal to L divided by G. That's the square root sign gone. It's gone over to the left, so it's now a square. Squaring. Let's keep going. We can't leave that in brackets because I need to get my divide by G over there. And that's going to be a bit funny with all this. Even without it, the divide by G is going to be funny. So one of the bits I'll do now, just to make it clear with powers, is if I rewrite this without the bracket, what do I have? I have T squared. So the first term, the numerator to the power, the denominator also gets raised to the power. So the denominator now is going to be 2 pi. The entire expression, so I'm going to put it in brackets, has to be squared. The entire expression, 2 pi, has to be squared. And that's going to be equal to L on G. This is going to be a big one, and hopefully, you realize that this is a bit more complex than the ones that we were coming up in. This is 38B, so 37B. Yeah, these we're up the game a bit. Concentrate. Let us see where we go from now. We need to deal with this. That's why I put it in red. We need to work out what is 2 pi squared. And at this stage, raising to the power, it's the 2. Let's do that in green to make it clear. It's the 2 has to be squared, and also the pi has to be squared. So what do I end up with? I end up with t squared all being divided by 2 squared is 4, and pi squared, well, pi squared. So I have t squared on 4 pi squared, and that is equal to L divided by G. Had a bit of work to do on the left hand side, and now we're almost done. I want L. Sometimes you gotta remind yourself, what was the question? What was I trying to do again? And I'll scroll back up and see, well, the question was make L the subject of the formula. That's what we're trying to do. We were rewriting this expression so that L becomes the subject of the formula. So I'm working through, and I want L all by itself. That's what we want. So let's go back down. And now L all by itself. At the moment we have this, the fraction bar means to divide, so we have divide by G on the right hand side. It needs to go over to the left, so which means I need to multiply by G. So multiplying by G, I have the t squared on 4 pi squared. It has to be multiplied by G, and perhaps easier to make this clearer is saying that it's multiplying by, and I'll put it in red, multiplying by G divided by 1. And I've put that so that makes it the multiplication easier to do. Because what you're going to do now, we'll deal with that in a moment. We now have L all by itself, and it's almost game over. We just need to tidy up. We don't use the multiplication sign in our expressions in algebra, so that needs to go. Hopefully by putting G divided by 1 has no effect, but it makes it really clear that the G, how do we multiply fractions? We multiply the numerators, we multiply the denominators, and you should be smiling now because that means I'm left with t squared G, and then the 4 pi squared multiplied by 1, well, that is just 4 pi squared. So t squared G on 4 pi squared, that will give me L. That is your answer there. Oh yeah, oh yeah, oh yeah. That is what we're talking about. I've just gone through this one in detail. Hopefully it makes sense. You're thinking, yeah, I can do this. And it might be you have to watch it over and do it. But if you didn't do it yourself, you might I would recommend, you know what, just take a step back, write down the original problem, and actually try and do it for yourself now. See if you can work through step by step the entire process, because things are getting complex now, and that's the way it has to go. It has to start getting complex. So that's an approach you might want to take there. Now where are we gonna go? I'm gonna look at another example. A couple others actually, and then I'll give you a few questions to try. Just a few of these. We're just building this topic. Further building on our work. So we want to make X the subject of the formula here, and I will ask you, yeah, go on. This one is more straightforward, I think. That I should have opened with this one actually. I should have opened, but I was copying the MEP book, and they had this as the second one. Yeah, I should have gone with my gut feeling and started with this one. The difficulty here, you have the power to pause. You do use the power to pause to spend some time with it, and and then you're working with me. So the issue here with this expression is that actually there's no issue. I want the X all by itself. So the first thing, I have positive 6, and the 6 needs to go on the other side. So y plus 6 is going to be equal to minus 5x. And you start seeing what the issue is. The minus 5x. How do you deal with the minus? Okay. Well, the next piece of logic you can take that will deal with the job, but it's not ideal, but I'll show it to you anyway as an approach, is where, well, at the moment what's happening, x is being multiplied by minus 5. It's being multiplied by minus 5. I don't want to multiply by minus 5. I want x all by itself, so x is going to stay all by itself, and that means the expression on the left hand side, the y plus 6, needs to be divided by minus 5. Now, there's where we sort of run into an issue. It's not wrong. This is correct. But the minus sign, and yes, what we can do if you're thinking, well, where can we go with this? Well, the convention is you'll put the minus sign in front of the entire expression, and we'll have y plus 6 on 5, and that is equal to x in front of the fraction. So, for example, what am I saying here? If I have minus 2 on 3, we would write it as minus 2 on 3, the minus sign in line with the fraction bar. Even if I had 2 on minus 3, I would also write it as minus 2 on 3. Okay, the minus sign in front of the fraction. Because the reality is, it doesn't matter if the negative sign is in the numerator or denominator, you're still going to get, numerically, it's the same value. And it looks prettier if you write it like this. So that's the logic I was going with there. I'm going to rub that off so it doesn't create any distraction in terms of all work. And I was just thinking, I want to keep it because I might want to use that after, but hey, it goes. So are we right there? Yes. Can we do this question nicer and not have to have that minus sign in front of the fraction? There's a yes to that as well. And the approach we'll take, and this is the preferred approach. If I have y is equal to 6 minus 5x, then the first step strategically we'll do is actually the entire minus 5x, we can move that to the left-hand side to make it positive. So minus 5x goes onto the left-hand side and it becomes positive 5x. So I have positive 5x, and I'll leave the y. I'll put the y first for simplicity here. So y is not going anywhere. I have y, and now on the left-hand side I have positive 5x, and that is equal to 6. And then from there, now the y needs to go, because remember we want x all by itself, so the y needs to go onto the right hand side, and it's positive y. So on the other side it's going to become negative y. So what we're going to have, we're going to get 5x is in its home, so it's going to go green. 5x is equal to 6, and the positive y goes on the other side and becomes minus y. And finally, we don't want 5x, we want x. And so at the moment, what's happening? X is being multiplied by 5. Okay, that's x multiplied by 5 is being multiplied by 5. We want to do the opposite of multiplying by 5, and that's dividing. So the expression on the right, the entire expression has to be divided by 5. So our final line, x is equal to 6, take away y, and the fraction bar divided by 5. That's what happened. The multiplication by 5 became divide by 5. And you can see in this version, we have no negative sign in front. It looks prettier. X is 6 minus y on 5. And the thing you have to ask yourself now is, well, hang on, are these expressions the same, or are they both correct? And the answer is yes, they are both correct. They are actually the same. Because look at this, just the denominators are the same in the final format. The denominators are the same, divide by 5, divide by 5. Let's just think about the numerator and know what I talked about with the fractions after. Whether I put the minus, where I put the minus sign, numerator, denominator in front, it does not change the value. So in this case, I'm going to use the numerator. I'm going to think as the numerator as a negative value. And, well, what do I have? Let's just put this down here and explain this. 6 take away y. That's what we had here, and I'll put it back in green actually. 6 take away y. So we have 6 take away y. On the other side in blue we have minus y plus 6. And what I'm saying is that they are equal, because all that's happened is the order. Remember, what is that 6? Is that 6 positive or negative? The 6 is positive. So actually, if I change the order, so what do I have here? I have a positive 6 and negative y. So if I was to change the order, look, I have negative y, I have positive 6. They're equal. It's just written in a different form. Instead of writing minus y plus 6, it looks nicer to write 6 take away y, but they're the same. You can try it. If I told you y is 2, 2 take away, so if y is 2, 6 take away 2, 4. Yeah, 6 take away 2 is 4. If y is 2, minus 2 plus 6 is 4. It works. Okay, so they're the same. The expressions are the same. The one on the left, preferred. So I'm going to put this as right, preferred. Okay, that's it, your preferred method there. Okay, so that's something for you to keep in mind there. Either answer is right. Okay, now let us look at one more. Then I'll ask you to try one of each. That's what I'm going to do. Ask you to try one of each before we finish off on these. At least one of each, really, because I call this B version of 38 has to be a bit slower. Yeah. Let's look at this one. Now we want X to be the subject. So I want X all by itself. So the first thing I'm thinking, the first thing I will do is plus 1 on Y needs to go onto the left-hand side. Change the side, change the sign, or do the opposite operation. Instead of adding 1 on Y, I want to take it away. So I'll write as my first line, Q, take away 1 on Y is equal to 1 on X. Okay, that's the starting point. Now, there might be a temptation here to think, reciprocals. If 1 on X is this expression on the left, then if I invert everything now, I'll have the answer and I'm done. If you're thinking that, if that came to your mind, no, doesn't work. And you can try it with numbers and see that it won't work. In essence, the reason it won't work is because you have an expression on the left-hand side, and the only way you can do that procedure of doing that inversion, using the reciprocal, that the reciprocal on the right-hand side is the same as the reciprocal on the left, is if it's a single term. So we need to combine Q, take away 1 on Y. We need to rewrite it as a single term. How do we do that? Well, let's think about it a bit differently, and let's say we have Q on 1 minus 1 on Y is equal to 1 on X. And the only way, recall that the only way you can subtract fractions is if the denominators are the same. Right now, Q has a denominator of 1, because dividing by 1 doesn't change the value, that's why. So any number is the same. So if I have the number 2, it is the same thing as 2 on 1. If I have the number 3, it's the same thing as 3 on 1, and so on and so forth. So you can use that strategy to frame your values as fractions when necessary, and make calculations easier, or make it clearer what calculation you should do. So the denominators are different. I need to make the denominators the same. So I want the lowest common denominator and the lowest common multiple. And well, 1 goes into everything. I want Y. So the denominator we're going to use is Y. And then you ask yourself, well, what did you multiply 1 by to get Y? It's Y. So Q has to be multiplied by Y. So I get Q, Y. And then, well, 1 on Y is going to still be 1 on Y. Now I have a single fraction. QY take away Y divided by Y is equal to 1 on X. And you're probably thinking, why? Why? Because I'm saying Y so much. But with that move, now that we have a single term on the left-hand side is equal to a single term on the right, one fraction, a single fraction on the left is equal to a single fraction on the right, now we can perform the inverse. We can do the reciprocal. I can write that X divided by 1 is equal to Y over QY take away 1. We can only do that. That was the big idea I'm trying to get across with you. We can only get to that stage. Let me just space things out. Would it be beneficial to space things out? I can't anymore, actually. But we can only get to that stage. Ooh, I didn't move the equal sign. That's a bit of a problem. We'll leave it like that. We can only get to that stage when we do, when we make the when we have one single fraction on the left. That was the key thing there. So let's look back at what we happened. We did here. What was the process? We want to find the value of, we want x to be the subject, not 1 on xx. So x has to be the numerator. And we don't want a fraction at all, really. We want to get rid of the divide by 1. So I'll deal with that when we get back there. At the moment, we're adding 1 on y. We don't want to do that, so we want to move the plus 1 on y to the left, so it becomes minus 1 on y. Then we have two terms on the left, or the subtraction. We want to make it one single fraction, so we need to actually perform the subtraction. The only way you can subtract fractions is if the denominators are the same. So we have identified y as the lowest common denominator. We've written q on 1 as qy on y, because the y's would cancel, giving you q on 1, or q. And then 1 on y remains the same. Now that I have the single fractions, I can flip over, because it's effectively saying this. If I look at this and see if this works. If I have 1/2 plus 1/3, that's 5 on 6. Okay. If I combine two threes, if I don't do the combination, this is the idea I was trying to get at you. If I just invert everything, I will be saying 6 on 5 is 2 on 1 plus 3 on 1. And well, that's not true at all. You can quickly work out 2 on 1 plus 3 on 1 is 5. And well, it's not true. Well, actually, the first one is true. It's when we do the inversion, it's not true. Because 6 on 5 is not equal to 5. Okay, so I'm trying to show you why there's an issue. However, so that's not true, but if I actually do the addition, if you actually perform the addition first, lowest common multiple, 6, multiply by 3, you get 3 on 6, multiply by 2, you get 2 on 6. Now I have the left-hand side and the right-hand side equal. So that's the logic we have worked through here. Hopefully, if you weren't seeing it by me doing this, you think that's your aha moment. I'm hoping you got an aha moment. And really, all that's left to do here is, well, two things. We want we can swap around sides. X on 1 is equal to y on qy, take away 1, and then really to tidy everything up, it's the idea that we don't need to divide by 1. We want x by as the subject, so x is equal to y on qy, take away 1. So that's what we're looking at there. We will stop there in terms of more complex formula. It does get even more complex, but I think we've gotten to a good position now. I'll ask you to do one of each, at least one of each, or I'll ask you to do one of each of these, and then we will review what we've learned so far, and we can take things further in another task. Okay, so let's just do one. We've gone through 3 rather interesting ones. Let's get one of each done. Here are the first 2 questions for you to try. While you're working out, etc. You pause, use the power to pause, and it's you working through. I'm just going to give you the answers. So you've paused, you've had a go. These are the answers you should have for question 1 and question 2. So part 1 and part 2, those are the answers you should have. Please mark your work. Now let's do another one, question number 2. Let's look at this one, a word problem. We're going here. You pause, use the power to pause, and you have to go. Good stuff, good stuff. You're smiling, you're feeling it. How you feeling? How you feeling? I'm about to give the answer. How you feeling? Let's see. D. Oh. Gotta scroll down. Hold on. There it is. The part A, part B. That's what we're looking for. Is that what you have? Please mark in green. You want to be using a different color pen. That's quite useful there. And then finally, last one I would like you to do. Last one I'd like you to do on 38B, task 38B, if you'll be so kind. I think this takes things down a bit, but I put in this one because there's a question on a recent exam paper. I had a question similar, something along the lines of this, so I thought it was good to put it in. So off you go with question number 3. P3 is yours. Power of the pause. You're working on it. Thank you very much. Thank you so much. And we'll finish off. I'm going to put the answer. Here it is, part A. Whoa. What happened there? Here it is, part A and B. That's it for you there. And that's it for 33B. When we, for task 38.3B, you'll get an assessment to do some questions on this. Is what we'll hope we'll have some more. You'll have a chance to have more practice via your teachers or your school. And next time I look at formula 39, probably 39. We'll up the game and make the formula even more complex because there's more complex formula out there. So that's going to come up in 39. As of creating this video, this one is the last one we're doing on formula before the what would have been the half term. Well, what is half term holiday? So enjoy your half term holiday if it is that you're looking at this before the half term, and we will continue. We'll go further. 39 will be released after the half term. That's when that's going to come up. Bye bye for now.